You've probably heard of the monosaccharides glucose and fructose before. They're the two probably most common monosaccharides that are inside of our diet as well as in our bodies. And while there are absolutely 100 more probably monosaccharides that we could possibly sort of think of and synthesize, galactose is another monosaccharide which isn't really as common as the other two and sort of gets brushed under the rug when sort of talking about sugars inside of our diet. And today I'm going to go through the sort of metabolism of galactose into glucose. Now, galactose looks very, very similar to glucose, but even though galactose, sort of when it's absorbed into the bloodstream, it's commonly found in dairy products and things like milk. When it's absorbed into the bloodstream, it still can't contribute to blood glucose levels, and so it will have to circulate around the bloodstream and be metabolized by the liver, and then it will end up being able to contribute to blood sugar levels. Now, I'm going to quickly go through the sort of differences between glucose and galactose, and both are sort of represented in a sort of visual, easy to understand way by hexagonal rings. Both are sort of seen that way in the kind of school textbooks, etc. And I'm not actually quite sure on the exact differences. I'm pretty sure it's just sort of switches around of the sort of OH hydroxyl groups. I'm 90% sure it doesn't really move the position of the oxygen double bond or the CH2OH groups. I'm pretty sure it's just a small sort of rearrangement of different OHs that ends up meaning that it can't contribute to blood sugar levels and has to be metabolized by the liver first. And that's exactly what I'm going to go through in this quick little video. But while galactose can be found in very small amounts inside of our diet, it's more often produced by a different type of sugar known as lactose. Lactose is made up of two separate galactose molecules, and lactose ends up producing two galactose molecules using the enzyme lactase. Now, people who are lactose intolerant who may be watching this video, you do not have the enzyme lactase inside of your gut, and this means this reaction for you simply doesn't happen, and you cannot get that galactose being absorbed into the bloodstream, and it just isn't news for your gut because your gut then has to actually process that lactose in different ways, and it just doesn't end up being good for you whatsoever. But for the small amount of galactose that is in your diet separately, that will end up being absorbed, etc., etc., and all the stuff that we're going to talk about for the rest of this video will happen. But if you are not lactose intolerant, then lactose will be broken up into two galactose molecules using the enzyme lactase, and that is a simple chemical reaction that happens inside of your gut, but not your liver. But the first reaction step inside of the galactose metabolic pathway from galactose to glucose inside of the liver is galactose either producing one of two molecules, which are galactitol or galactose 1-phosphate. Now, these reactions are catalyzed by the enzyme galactokinase, and I've talked about what exactly a kinase is before, and a kinase is something that sort of adds a phosphate group onto a certain molecule, but the two molecules that I mentioned, galactitol and galactose 1-phosphate, it's not that every single reaction that happens produces one of these molecules each. It's that galactose can either be transformed into galactitol or galactose 1-phosphate, depending on maybe a few certain circumstances, a few reaction inhibitors, etc. But it's very much different to a reaction I talked about in the fructose metabolism, which was fructose 1-phosphate turning into glyceraldehyde and DHAP using the enzyme aldolase B. Now, every single reaction would have produced both of these molecules, but that is completely different to how the reaction that we just talked about works when galactose ends up producing galactitol or galactose 1-phosphate. Now, galactitol is completely irrelevant to the metabolic pathway, and we want to continue with galactose 1-phosphate and go on to the sort of second or third reaction step inside the metabolic pathway. And that is galactose 1-phosphate plus UDP glucose turning into glucose 1-phosphate and UDP galactose. Now, this reaction is catalyzed by an enzyme with a very, very, very long name, but it just starts with galactose kinase 1-phospho, and it's just all very confusing, and I can't remember the exact name off the top of my head. I ended up just not being able to fit it on my scripting page because it was so long and so large. But this basically just sort of just switches which molecules has a 1-phosphate or a UDP group attached to it. And glucose 1-phosphate is a very important molecule because it is involved in the glycolysis and glucogenesis pathway. Now, these two pathways, glycolysis and glucogenesis, are incredibly important things that happen in the majority of cells inside of your body to either produce or use energy depending on what's needed and depending on your bodily circumstances. It's a very sort of interesting thing that I'm going to do a whole separate video on, but glucose 1-phosphate does end up producing glucose using a certain enzyme which I can't remember, but I will go over that all in a separate video because otherwise it will just take far too long in this one video to sort of only end up covering half of the glucogenesis or glycolysis pathway, depending on sort of which way you're going about it. And I'd much prefer to sort of cover that straight up in one whole big video, which would end up taking like 20 minutes or whatever. But yeah, I really hope you sort of enjoyed this video on the galactose metabolism pathway. Maybe you learned a bit more about how lactose intolerance actually sort of works, and I also highly recommend subscribing because I love this community of young tribal people who are willing to improve themselves so much more than they already have, and good luck.